Welcome to classes by Inspire Physics. Today we have the topic LC oscillations. See what happens when we connect an inductor and a charged capacitor in parallel. So this circuit will produce some oscillations just like a mechanical oscillations. See, already we know what is mechanical oscillation. See, in simple pendulum there is oscillation, or for a spring if it is compressed and released it will start to oscillate. Just similar to that of mechanical oscillation, there are oscillations produced in electrical circuits. These circuits are called LC circuits. Okay. Now we have an inductor. Say I'll just start with another diagram. We have an inductor having self-inductance L. It is connected to a capacitor. Say we have a capacitor. Let a capacitor is initially charged. See, there are a few charges in capacitor. One plate is positively charged, the other is negatively charged. CB the capacitance. So in this capacitance, energy is stored in the form of electric field. What is the equation of energy stored? We can say energy is stored in capacitor. We can say electric energy is equal to Q square by 2C. Okay, that's the general equation. Now for this closed circuit, we know that there is a potential difference across the capacitor. What's the equation of potential difference across capacitor? It is Q by C. We can use the equation Q by C. Then if this charge flow like this, positive charge flow through the inductor, there will be variation of current. Means current grows in this direction. This will produce magnetic field around the solenoid. Okay. So it will produce some EMF by self-induction. See, initially we are just switching off. We have a switch. If it is switched off initially, then when you suddenly switch on, the current grows. This change in current will induce an EMF by self-induction. What's the EMF induced? By self-induction, we know that EMF induced is minus L into di by dt. We know the equation. Okay. Now we can apply Kirchhoff's law for the closed loop. When we apply Kirchhoff's law, we have Q by C minus L into di by dt. It will be equal to 0. But we have I is equal to minus a dq by dt. Charge is equal to current is equal to, why there is minus? When charge is decreasing, the current will be increasing. See, they are opposite of nature. That's why I have put a negative sign here. Then when you substitute I here, what will you get? Q by C minus minus will become plus L into I means dq by dt. When you differentiate this once again, you will get d square q by dt square is equal to 0. Okay. Now we need to rearrange this. When you rearrange d square q by dt square plus q by L C, we divide throughout by L, it will be equal to 0. We can compare this equation of second order differential equation. We know for oscillation we have the equation d square x by dt square plus omega 0 square x. We can say it is equal to 0. Comparing, we can say what is omega 0 square? Omega 0 square means square of the frequency, angular frequency is equal to 1 by LC. Or what is the frequency? Frequency equal to 1 by root LC. This is the frequency of oscillations. Of the natural, like we can say this is a natural frequency that depends on the values of inductance and capacitance. Okay, we have got the equation. Omega 0 is equal to 1 by root LC. Now the solution of this equation, the second order differential equation, we can say solution is instantaneous charge is equal to Qm. Qm is a maximum charge. Qm we can say as cos omega t plus phi. Cos omega t plus phi we can use. Phi is the phase, initial phase. Now at the instant when time is equal to 0, when time is equal to 0, what will be the value? We can say charge will be maximum charge. Capacitor is charged maximum. When we start with the capacitor is charged maximum, that is Qm. So how can you write? Qm is equal to Qm into, this will be 0. We can say cos phi. Or we can say cos phi is equal to 1. When cos phi will be 1, the phi angle should be 0. Okay. Substituting this, we can say instantaneous charge Q is equal to, we have the equation instantaneous charge Q is equal to Qm. Phi is taken 0. Cos omega t. Okay. Then what will be current? Current I is equal to dq by dt. When you use current I is equal to minus dq by dt, we can write equation I is equal to minus d by dt of qm cos omega t. You can say cos omega 0. Omega 0 is a frequency. Cos omega 0 t. Cos omega 0 t. Okay. We need to differentiate this. I is equal to minus qm. We have differential of cos. Differential of cos is minus sine. So it will be plus sine omega 0 t into omega 0. Or what is I? I is equal to omega 0 qm sine omega 0 t. Okay. So this one will be equal to peak value current. I can say I is equal to Im sine omega 0 t. Sine omega 0. This is the equation of instantaneous current. Instantaneous charge, we have the equation number 1. This is instantaneous current. Current which is flowing through the inductor. From the capacitor, there will be current flow to the inductor. This will be the equation of current flowing through the inductor. What is Im? Im is equal to omega 0 qm. Okay. We can say Im peak value current is equal to omega 0 q. Okay, so we can say this circuit is behaving like an oscillator, because this is the equation for a harmonic oscillator, so second order differential equation. We have got a similar equation. We can say that there will be oscillations produced. So this is a theoretical part. We have seen the principle and theory behind it. Now we actually see what happens in an LC circuit. See, we have a capacitor. Capacitor is initially charged, so there are large number of positive charges on the first plate, and the next plate we have a negative charges. Okay, now key is open. Now initially the key is open. Now when the key is open, this will contain maximum charge. We can say the energy stored. We can, what is the energy here? You can say UE. What will be UE? It will be equal to maximum charge. What is the maximum charge? Maximum charge is QM. So qm square by 2c. What about the energy in the inductor? We can say U magnetic field. Energy is stored as magnetic field inductor. Um is equal to 0. There is no magnetic field. Energy will be 0. Now in second situation we are just going to close it. Now key is open. Okay, key open. I'll write here key open. This situation. When key is closed, what happens here is current will start to flow. So the charge from the capacitor will start to decrease. I had drawn only 2 charges on either end. There will be current flowing in this direction. I start to flow. So the current grows. We can say current start to develop. When current start to develop, there will be what will be developed here? There will be magnetic field developed. In a particular direction, there will be magnetic field developed. One end of the solenoid inductor becomes north pole, other end will become south pole. Current is growing. When current is growing, magnetic field will be increasing. This increase in magnetic field, it will induce an EMF, induce a current by self-induction. See, there is increase in current, it will produce increasing magnetic flux. There is magnetic flux increasing. This will produce what? It will produce? It will produce what? An induced current. What's the nature of the induced current? To oppose the actual growing current. I can say the induced current will be flowing in this direction. See, this is the direction. Induced current. Growing current in this direction, induced current in the opposite direction. Now we can say partially, I can say UE. UE, there will be some energy in the capacitor's electric field. UE not equal to 0, I can say. And what about UM? UM also not equal to 0. Some energy will be in the form of magnetic field in the inductor. Some part of energy will be in the capacitor's electric field. There are 2 forms of energy. See, what's the direction of induced current? Actually, growing current in this direction, induced current will be in the opposite direction. To oppose by Lenz's law, we know that it will try to oppose back EMF. Okay. Now in this next step, we can see that it is completely discharged. The entire charge is lost. The charge will start to flow in this direction. Plus charge moves like this. It will completely discharged. Now what about UE? Electric field. There is no electric field. The energy due to the electric field will be 0. Capacitor is fully discharged. Then what happens is, what about here? There will be large number of magnetic field lines. See, strong magnetic field. We can represent like this. It is maximum. So what is the energy? Um will be, maximum energy will be there. We have equation half Li square. Half Lim square we can use. What is Im? Im is the peak value of current. Im is maximum energy in the magnetic field. Okay. UM means energy in the magnetic field of the inductor. This is a maximum energy. Now there is no charge in the capacitor. Now what happens? This magnetic field start to decrease. The magnetic flux start to decrease. Here there is increase in magnetic field. Now a charge in the capacitor. Now current is flowing. Magnetic field start to decrease. When magnetic start to decrease, actually when magnetic was increasing, induced current was in this direction. When magnetic field decreases, that also change in magnetic flux. By Lenz's law, it will produce an EMF. Or by Faraday's law, Lenz's law, it will produce an EMF. In which direction? See, when our flux was increasing, which was the direction of induced current, opposite to this. This is the direction of induced current. Okay. Now, when the flux is decreasing, what happens? Induced current will flow in opposite direction. In which direction? Opposite to this. This will be the direction. So, in this direction, there will be induced current. We can say there will be induced current in this direction. Now what happens when induced current is flowing in this direction? The magnetic field will go on decreasing. Okay, magnetic flux go on decreasing, start to decrease. It will be partially charged, not fully charged. What about the charge? Say type of the charge. See, current is flowing like this. Means electrons are flowing in this direction. See, this plate will lose electrons. It will be positively charged. This will be negatively charged. We can say it starts charging the capacitor in the opposite polarity. Initially left plate was positively charged. Now right plate starts to charge positively because the current is in opposite direction. This is the induced current. In this direction we had induced current when flux was increasing. Now flux is starting to decrease because there is no supply providing. So the magnetic flux start to decrease suddenly. It is just like switching off. Magnetic flux start to decrease. This decrease in magnetic flux by Lenz's law should induce an EMF, induce current opposite to this current. This was the direction of current, now opposite direction. In this direction, current start to flow. This current will charge the capacitor in this manner. Okay, now what about the energy? So both will be partially energy. There will be some energy in the electric field not equal to 0. We can say in magnetic field also the energy is not equal to 0. Some partially energy will be stored in capacitor as well as in the inductor as magnetic field. Now last situation, this current flow stops when the capacitor is fully charged. See, capacitor is fully charged. There will be large numbers fully charged. Current flow stops. There is no magnetic field here. I can say UM should be 0. No energy in the inductor, but there is energy in the capacitor. Okay, electric energy given by QM square, maximum charge square by 2C. Okay, now we have got this situation. Now this process repeats. This is we can say one cycle of operation. In one cycle, it is charged in one direction. Now it is charged in opposite direction. This process repeats. So this process repeats and it will produce such oscillations. Charging and discharging capacity. This is charged. It is discharged. Again charged in opposite sign. So charging and discharging capacity take place continuously. This will produce oscillations. So what is the frequency of oscillation produced? We have frequency oscillation produced will be equal to 1 by root LC. It depends on the values of the inductance which we use as well as the value of the capacitor that we use. Okay, that's about LC oscillations. So it finds many applications, means in oscillators to produce alternating current we can use this LC oscillations. Okay, thank you.